These observations taken measurements of the Perdeberg Dam in the Cape province, not far from Somerset West. The survey was done local with WGS 19, WGS 84, LO 19 using an MLID GPS. Just to give you an idea of the terrain there. As you can see, the dam was fairly low as compared to where we are now. This is the survey result. 1.29 centimeters GSD, ground survey distance, and it was Phantom 4 Pro. The camera optimization was good, so all conditions were good. Control RMS error 0.023, and the heights were obviously a lot better than that. Not that we are millimeter surveyors. We're not surveyors, observers. You can see the Z error was well below 50% of any requirement. This resulted in a pretty good model, as you can imagine. From that, I was able to measure the heights of the spillway. You can see the 3 millimeters. I'm not a millimeter surveyor, etc. So there we have the heights, 428, and as per tabulation you'll see just now. We also measured height of water. Now, one of the reasons we had the control space strategically around the dam, on the dam and there, so that we could utilize images very close to each other in time, so that Pix4D we can actually measure something on it. Here you can see we have measured on the top of the spillway, or the bottom of the spillway opening, and here we've measured water. You can see we had a wave situation there, which was quite a fierce wind. This bathymetric measurement was done with radio control, so you did a pretty good spread, as you'll see in a moment. So you can see the waves are actually quite high in some places. So let's have a look at the tabulation. Okay, spillway, that's the average is 428.07, and there the average water heights. So we got 426.31, which is a difference of 1.76. We'll come back to the rest of these in a moment. So from this we took the data into first of all the bathymetric data. We converted from from WGS 84 latitude and longitude. Now the sounding is what it does on the CSV that you get from the sonar device. It gives you a coordinate and a height or depth, and it will measure 10 or 15 at that same soundings at the same position. So if you just delete all the duplicates and then import the CSV or tab text file into Survey Maker or whatever device you have, and convert to LO19, I beg your pardon, and here's the result. We export that as an MMS file, which we bring into Model Maker, and we have the we have two here. We have the 15 degree and the 55 degree cone. The 15 degree will actually penetrate to the bottom through to the hard, and the 55 will pick up vegetation and an apparent silt level. From this we just go to cut and fill, and we will select, for example in this case, so we're going to go from the water level the water level to the high level mark. How do we get there? We'll show you in a moment. We'll just do let's do that first, in fact. So let's switch that off. So on Survey Maker, I beg your pardon, on Pix4D we established the height of the high level mark, and now we're going to ignore the sorry about this display. Let's just get this up here. Okay, from that we determined that a 2 meter contour would be quite sufficient, because we were in fact looking for the 428 contour, and there it is there. Now what we did further was we established the water line, on 3, we established the water line by means of a polyline. So it's very simple then to add the required. So we're leaving this elevation, in fact, and now concentrating on the actual dam. It's very simple. It's just point add polyline. So you just check it onto a node, and it'll go all the way around. Select the whole polyline, and you tell it what you want. Z value 0, Z value 0, interval 5. Okay, so that's already done. We do the same thing with the high water mark. You will notice that we are putting in a 1.76, which is the height from water level to top level, and we triangulate those two elements. So we obviously now we can do hard bottom to top, hard bottom to water level, and we can do soft bottom to water level, and we can do water level to the top, giving us 3 options with of volumes. Let me just demonstrate this. Let's do 3 and 4. Okay, that is from the water level to the high water level. Okay, grid. Okay. And there's that volume, 56507. As we've done this previously, now let's have a look at the tabulation. Okay, so the hard bottom to water level, 181,522. From the water level to high water, 56507. Total volume indicated 238,029. Designed 236,000. That's less than 1% differential, which is more than acceptable. Silt to vegetation, 175,330 cubic meters. The differential is 6,000 indicated vegetation and silt. So as you can see, we have a very accurate observation of the spillway height and of the water in the particular areas where the images are like within seconds of each other. So Pix4D was able to give us an accurate value there. So without a doubt, this inexpensive, simple to operate system is certainly a game changer in this country. Thank you very much. And there's an example of the output from Model Maker.